Imagine waking up on a normal morning with no idea that the world around you is about to disappear. No warning siren, no emergency alert, no one running through the streets telling people to leave. Just the sea, the sky, and a volcano that had been smoking for months. Then, in one terrible moment, Krakatoa exploded. The sound was so powerful, it was heard thousands of miles away. People in distant places thought they were hearing cannon fire. Windows shook, instruments broke. Ships far out at sea felt the blast like a physical hit. This was not just noise. It was pressure moving through the air like an invisible wall. And near the volcano, it was even worse. Some sailors were so close to the blast that their eardrums burst. Men were bleeding from their ears. The world around them suddenly sounded muffled, like someone had shut a heavy door between them and life itself. But the sound was only the beginning. After the eruption, the sea rose up. A tsunami, more than 100 feet high in some places, rushed toward the coasts of Java and Sumatra. Entire towns were wiped off the map. Homes, streets, ships, trees, people, everything was taken in minutes. By the time the morning was over, more than 36,000 people were dead. Think about that for a second. Not over a year, not over a season. In one morning. And the strange part is, Krakatoa was not some unknown mountain hiding in the middle of nowhere. People knew it was there. Officials knew it was active. Scientists had been watching it. Ships had reported smoke, ash, sulfur, strange waves, and floating pumice around the island. The signs were there, but the meaning of those signs was missed. That is what makes this disaster so disturbing. It was not only a story about nature being powerful. Everyone knows nature can be powerful. This was a story about people seeing danger and still not understanding how close they were to the edge. The volcano had been quiet for a long time. Then it started waking up, slowly at first. A little steam. A few earthquakes. More smoke. More ash. More strange reports from passing ships. And still, many people treated it like a curiosity. Something interesting. Something worth writing down. Not something that could erase whole towns before lunch. Then came the 27th of August, 1883. Krakatoa did not simply erupt. It tore itself apart. The explosion sent shockwaves around the planet. The atmosphere rang for days. Barometers in faraway cities recorded the pressure wave as it circled the Earth again and again. The sky changed color across continents. Sunsets turned blood red. The air carried volcanic dust around the world. Temperatures dropped. Crops struggled. People far from Indonesia looked at the strange sky and had no idea they were seeing the fingerprints of a disaster from the other side of the planet. That is why Krakatoa still matters. Because it reminds us that a disaster does not always begin with panic. Sometimes it begins quietly, with a little smoke, a few small tremors, a report that sounds unusual but not urgent. And then one morning, the warning becomes history. Krakatoa sat in one of the most dangerous places on Earth, even if most people at the time did not see it that way. It was in the Sunda Strait, the narrow stretch of water between Java and Sumatra. On a map, it may look like just another island in Indonesia. Small, remote, easy to overlook. But underground, it was sitting on a line of violence. This is where massive tectonic plates push, grind, and press against each other. The Australian plate moves toward the Eurasian plate. It does not happen fast enough for a person to notice in daily life. But over millions of years, that slow pressure builds mountains, opens cracks, and feeds volcanoes. Krakatoa was part of that system. It was not just a mountain with a hole at the top. It was a pressure point, a place where heat, rock, water, and trapped gas were all connected deep below the surface. And that matters, because Krakatoa's danger did not come only from lava. Most people imagine a volcano as red lava flowing down a slope. That is scary, of course, but Krakatoa was different. Its real threat came from where it was located. It stood in the sea. That meant magma and seawater could become part of the same disaster. And when water meets extremely hot magma in a confined space, the result can be explosive beyond imagination. That is what made Krakatoa so dangerous. It was surrounded by water, built over unstable ground, and tied to a deep geological system that had been active for millions of years. The volcano could sleep for a long time, then wake up with a kind of violence that people were not ready to understand. For about 2 centuries, Dutch colonial authorities had known about the volcano. They had maps, they had records, they had people watching the region. So Krakatoa was not a surprise in the simple sense. It was known. But being known is not the same as being understood. That is the part that still feels familiar today. We often think that if something is monitored, it must be under control. If experts are watching it, then surely someone will know when to worry. But nature does not work like that. A volcano does not care how many reports are filed. It does not wait for people to agree on what the signals mean. It keeps building pressure until the system can no longer hold. In 1883, Krakatoa was sitting between 2 crowded islands, near busy sea routes, in a region where people lived, traded, traveled, and worked along the coast. It was not isolated from human life. It was woven into it. Fishing boats passed nearby. Merchant ships sailed through the strait. Coastal towns faced the water every day. For many people, the sea was food, travel, business, and home. But that same sea would become part of the disaster. The location of Krakatoa explains why the eruption became so deadly. It was not only the blast, it was the combination. Volcano, ocean, unstable island, and people living close to the shoreline. That is the terrifying thing about Krakatoa. It was not a random monster rising out of nowhere. It was a loaded system sitting in plain sight. The hardest part about Krakatoa is not that nobody saw it coming. People did see something. That is what makes the story so uncomfortable. In May of 1883, the volcano started waking up. Steam rose from one of its peaks. Small earthquakes shook the Sunda Strait. Windows rattled in Batavia, about 50 miles away. People noticed. They wrote letters. Officials heard about it, and the scientists did not ignore it. They logged it. They studied it. They wrote it down carefully. But they did not treat it like a deadly warning. They called it a reawakening. Some reports even described it as a curiosity. That word says a lot. Curiosity means interesting, strange, worth watching, but not urgent, not dangerous enough to move people away from the coast, not serious enough to make anyone say, "This could kill thousands." And that is where the tragedy begins. Through June and July, Krakatoa kept sending signals. Smoke rose and fell. Ash landed on passing ships. Sailors smelled sulfur in the air. The sea around the island changed color. Floating pumice covered parts of the water so thickly that small boats had to push through it. These were not tiny clues, they were loud clues. But at the time, the meaning was not clear. The Dutch had a strong observation system for that era. Barometers were working, seismographs were running, ship captains were keeping logs, geologists were collecting reports. The science was not asleep. The instruments were not broken. That is the scary part. The system worked exactly the way it was built to work. The problem was not that nobody was watching. The problem was that they did not understand what they were watching. They were collecting the ticks of a clock, but they did not know it was counting down. By July and early August, the earthquakes began to show a strange pattern. They were small, regular, almost rhythmic. Today, a volcanologist would look at that kind of pattern and take it very seriously. It can point to magma moving below the surface, pressure building, and rock beginning to crack. But in 1883, that language did not really exist yet. They had the data. They did not have the right meaning for the data. So the warning signs became notes in a journal, reports in an office, interesting details in a growing file. And while people were measuring, naming, and discussing, Krakatoa was changing underneath them. The mountain was not just smoking. It was weakening. The magma chamber below was shifting. Pressure was building. The island was becoming less stable, day by day. But from the outside, it still looked like a volcano doing volcano things. That is why this story still feels modern. Because we like to believe that once something is monitored, it is under control. We think data makes us safe. We think experts watching a danger means the danger will be understood in time. But Krakatoa proved something darker. A warning can be recorded perfectly and still be missed completely. And by the time everyone understood what those signs really meant, The volcano was no longer giving warnings. It was ready to explode. By the summer of 1883, Krakatoa was no longer being quiet. Ships passing through the Sunda Strait could see it. They could smell it. They could feel that something was wrong. This was not some hidden danger deep underground that nobody had a chance to notice. The volcano was showing itself in plain sight. Smoke kept rising over the island. Some days it looked weaker. Other days it came back stronger. Ash drifted through the air and landed on ship decks. Sailors smelled sulfur in the rigging. The sea around the island started to look strange, almost sick. One British merchant ship, the Charles Ball, passed near Krakatoa in August. Its captain, W.J. Watson, wrote down what he saw. Dense ash on deck, a strong sulfur smell, a steam column rising miles into the sky. That is the kind of thing that should make people stop and think. But at the time, it became just another entry in a captain's log. Then there was the water. The sea near Krakatoa was not clear and blue anymore. It was gray in places, brown in others. Pumice floated across the surface. Ash had cooled and spread into mats. In some areas, the floating rock was so thick that small boats had to push it aside with poles just to move forward. Imagine being there. You are on a boat. The ocean around you is covered with broken volcanic rock. Ash is falling. The air smells like sulfur. A volcano nearby is breathing steam into the sky. And still, the world does not react like a disaster is coming. That is what feels so frustrating about this story. The warnings were not locked away in some secret scientific office. They were being written down by people who were actually there. Sailors, captains, traders, men whose lives depended on reading the sea and weather correctly. They knew something was unusual. They just did not know how dangerous it was. And the reports kept moving through the system. They were collected, compared, filed, discussed. Geologists in Java gathered information from ships and towns. The Dutch authorities had records. The science of the time was paying attention. But paying attention is not the same as understanding. The ash, the sulfur, the floating pumice, the discolored sea, all of it was treated like volcanic activity. Serious? Maybe. Interesting? Definitely. But not the final warning before a massive collapse. Today, those signs would raise alarms fast. A volcano changing the color of the sea, throwing out pumice, sending ash onto ships, and building steam columns that high would not be brushed aside so easily. But in 1883, the danger did not fit neatly into what people already knew. So the signs became observations. The observations became paperwork, and the paperwork did not save anyone. That is the painful lesson here. Sometimes the people closest to a disaster see the truth first, but their warnings only become important after the tragedy has already happened. The sailors saw Krakatoa changing. They wrote it down. But no one looked at those notes and said, "This is the countdown." By the time the world understood what those floating stones and ash-covered decks really meant, the sea was already preparing to rise. This is the part that stays with me. The people around Krakatoa were not blind. They were not careless in the simple way we like to imagine after a disaster. They were watching. They were writing things down. They were collecting reports from ships, towns, instruments, and scientists. The barometers were working. The seismographs were working. Captains were keeping their logs. Geologists were sharing information across the strait. On paper, everything looked responsible. But that is exactly what makes it so chilling. Every signal was being recorded, but the deeper meaning was slipping past them. It was like standing next to a ticking bomb and carefully writing down each tick in a notebook without realizing the sound means time is running out. That is what Krakatoa was doing through the summer of 1883. Tick. A column of steam rises from the island. Tick. Small earthquakes shake the region. Tick. Windows rattle in Batavia. Tick. Ash falls on passing ships. Tick. The sea turns gray and brown. Tick. Pumice spreads across the water so thick that boats have to push it aside. Each sign seemed separate. Each one could be explained. A volcano waking up. Some steam, some tremors, some ash. Interesting activity, but not the end of the world. But together, they were telling a much darker story. The whole system under the island was changing, pressure was building, rock was cracking, magma was moving. The volcano was not simply waking up, it was becoming unstable. The problem was that nobody had the full picture in real time. A sailor saw one piece, a scientist saw another. A shopkeeper felt the windows shake, a ship captain smelled sulfur, a geologist read the reports and called the pattern interesting. But the disaster was not in one single clue. It was in the connection between all of them, and that connection was missed. That is something we still struggle with today. We can have more data than ever and still fail to understand what it means fast enough. We can measure, store, compare, and discuss. But if we do not read the pattern correctly, the danger keeps moving. Krakatoa was not waiting for people to finish their reports. It was changing hour by hour. By late August, the volcano had already moved beyond simple warning signs. The tremors were no longer just little shakes. The activity was becoming more continuous. The ground beneath the strait was not breaking in small pieces anymore. It was starting to fail as one system. But from the outside, people still saw smoke, ash, noise, and strange weather. They did not see the countdown. And that is the painful truth. A warning does not always look like panic. Sometimes it looks like a note in a logbook, a small line in a report, a strange reading on an instrument, a detail that feels important but not urgent enough to change anything, until it is too late. Krakatoa had been ticking for months. People heard it, people wrote it down, but no one understood that the final seconds had already begun. By August 26, Krakatoa was no longer just sending hints, it crossed a line. At about 1 in the afternoon, the first major explosion hit. A huge column of ash and steam shot into the sky, not a small plume, not a little burst from the crater. This was something massive, rising miles above the island. Anyone close enough to see it would have known this was different. The volcano had been smoking for months, ships had seen ash, people had felt tremors, scientists had written reports. But this was the moment when the warning signs turned into something much more serious. The British ship Charles Ball was still in the Sunda Strait, not far from the island. Its captain had already been watching Krakatoa with concern. Now, he saw the eruption grow into something violent. The sound was not like a single bang. It was a long, continuous roar. The captain compared it to a huge iron foundry running at full power. That image tells you a lot. It was not sharp and quick. It was deep, heavy, and constant. Like the inside of the earth had opened and was grinding itself apart. Ash began falling onto the ship. Hot ash. The crew had to keep sweeping the deck because the heat could damage the wood. Think about that. You are on a ship at sea, and volcanic ash is falling so hot that your job is to clear it before it burns into the deck beneath your feet. Then, lightning started striking the masts. That is one of the most frightening parts. Volcanic eruptions can create their own electrical storms. Ash particles crash into each other in the plume, building charge, and suddenly, the sky around the volcano starts flashing. So now the crew had ash falling, thunder in the air, lightning hitting the ship, and a volcano roaring behind them. At that point, this was no longer an interesting natural event. This was survival. The captain knew he had to get away from the island. The ship began moving toward open water. That decision probably saved lives. But even then, no one fully understood what was coming next. Because the explosion on August 26 was not the main event, it was the opening act. That is what makes it so disturbing. If you were there that afternoon, you might have thought you had already seen the worst of Krakatoa. A giant ash column, hot debris, lightning, a roar that seemed endless. But the volcano was only getting started. Below the island, the system was failing. The magma chamber was changing. Pressure was moving through the rock. The structure of the volcano was becoming weaker by the hour. The first explosion had released energy, but it had also damaged the system holding the volcano together. That is the part people could not see. From the surface, it looked like an eruption. Underground, it was becoming a collapse. By dawn the next morning, the ash column would grow even higher. The instruments would stop recording separate tremors and begin showing something more continuous. The rock beneath the strait was no longer breaking in small pieces. It was beginning to break all at once. August 26 was the day Krakatoa stopped warning people quietly. It raised its voice. And the next morning, the whole planet would hear it. The morning of August 27 did not begin like a normal eruption. It began like something was coming apart. By dawn, the ash column over Krakatoa had climbed higher than anyone nearby could ignore. The sky was dark. The sea was strange. Ships were trying to get away. Instruments on land were no longer recording clean, separate tremors. That detail matters. Before this, the ground had been shaking in pieces. A tremor here, a tremor there. But now the signal was becoming continuous. It was as if the rock beneath the Sunda Strait was no longer cracking one section at a time. It was failing as a whole. Then came the explosions. The first major blast of the morning struck around 5:30 a.m. One of Krakatoa's cones collapsed inward. Ash rose high into the air. For people along the coasts of Java and Sumatra, this was already terrifying. The sky had turned black. The volcano was roaring. The sea was restless. But that was not the worst of it. At about 6:44 a.m., the second explosion came. Another part of the island ruptured. The eruption column grew even higher. The volcano was not calming down. It was getting stronger. That is the thing about Krakatoa that feels so unreal. Each explosion did not release the pressure and end the danger. Each one made the system weaker. Each one tore away more of the structure holding the island together. Then, at 10:02 a.m., the third explosion hit. This was the one the world heard. Not just the people nearby, not just ships in the strait. The sound traveled across oceans. It reached distant islands and cities thousands of miles away. In some places, people thought they were hearing cannon fire far out at sea. But there was no battle. It was Krakatoa. That third blast lasted only a few minutes, but it changed everything. It blew apart a major part of the island. It sent a pressure wave racing through the atmosphere. Barometers across the world would later record that wave as it moved around the planet again and again. Close to the volcano, it was not just sound, it was force. The air itself became a weapon. The blast could injure people miles away. Ships felt it. Men lost their hearing. The sky, the ocean, and the island all seemed to move at once. And then, just when it seemed impossible for the volcano to do more, a fourth explosion came around 10:52 a.m. By then, Krakatoa was no longer the island it had been the day before. A huge part of it was gone. The volcano had not simply erupted from the top. It had torn itself open. The chamber below had lost support. The land above it was collapsing. Seawater was getting involved with the magma below, and that made the violence even worse. This is why the morning feels less like an eruption and more like a chain reaction. One failure led to another. One collapse opened the way for the next. One explosion weakened the system enough for the next one to become even larger. In less than 6 hours, Krakatoa went from a dangerous volcano to a planetary event. 4 explosions. One island breaking apart. A sound heard across thousands of miles. And nearby, on the coasts facing the Sunda Strait, people still did not fully understand that the worst danger was not only in the sky, it was also in the sea. Because after the explosions, the water was about to move. At 10:02 in the morning, Krakatoa produced the explosion. People still talk about today. This was the blast that made the whole world listen. Not in a poetic way. Literally, the sound traveled across oceans. It reached places thousands of miles from the volcano. People heard it in Australia. They heard it on islands in the Indian Ocean. They heard it in distant ports and coastal towns where nobody had any idea what had just happened near Java and Sumatra. Some people thought it was cannon fire. That is what makes the reports so strange. In several places, the sound was described like distant artillery. But when people looked toward the direction of the noise, there was no war, no battlefield, no ships firing guns, just empty ocean. The sound had come from Krakatoa. Think about how unsettling that is. You are standing somewhere far away, living a normal day, and suddenly you hear what sounds like heavy guns from a place where there should be nothing. You do not know that a volcano, thousands of miles away, has just torn itself apart. Near Krakatoa, the sound was not just something people heard, it hit them. It was a pressure wave, a moving wall of air, the kind of force that does not simply pass through your ears, but through your body. Ships close to the volcano felt it like a physical blow. Some sailors suffered burst eardrums. Men were bleeding from their ears. For a while, the world around them sounded distant and muffled, like someone had covered everything with a heavy blanket. That part is hard to imagine until you sit with it. The volcano did not just make noise. It damaged people with sound. And then the pressure wave kept going. It moved through the atmosphere at the speed of sound. It crossed oceans. It reached weather stations far from Indonesia. Barometers in cities on the other side of the world jumped as the wave passed over them. London saw it on instruments. Then Lisbon. Then Toronto. Then San Francisco. Then other places, one after another, as if the atmosphere itself had been struck like a giant drum. And the strangest part was that the wave did not simply vanish after one pass. It kept circling the planet, again and again. For days, instruments recorded the pressure wave moving around Earth. The atmosphere was still ringing long after the explosion had ended. A blast that lasted only minutes had created a signal that traveled around the world multiple times. That is why the 10-2 explosion is so hard to place in ordinary human experience. Most disasters feel local at first. A town destroyed, a coastline hit, a ship lost, a region changed. But this one touched the whole planet. People thousands of miles away heard the sound. Scientists far away recorded the pressure. Skies across continents would later change color because of what Krakatoa threw into the air. In that moment, Krakatoa stopped being just an island volcano. It became a global event, and the people closest to it had no time to understand any of that. They were not thinking about barometers in London or strange noises in distant oceans. They were facing darkness, ash, heat, falling debris, and a sea that was about to become deadly. The 10-2 blast was the sound the world remembered, but for the people near the Sunda Strait, it was something much worse. It was the moment the disaster fully arrived. After the 10-2 explosion, Krakatoa did something that almost sounds impossible. It made the atmosphere ring, not the ground, not just the sea, the air around the entire planet. When the volcano exploded, it sent out a massive pressure wave. Think of it like an invisible shock moving through the sky. You could not see it coming, but instruments could feel it. Barometers reacted as the wave passed over cities thousands of miles away. In London, the needles jumped. Then the same kind of movement showed up in Lisbon, then Toronto, then San Francisco, then farther and farther around the world. It was like the planet had been hit, and the atmosphere was carrying the bruise. That is what makes Krakatoa different from most disasters. A storm can destroy a coastline, an earthquake can level a city, a flood can swallow a valley. But Krakatoa reached into the air itself and sent a signal around the Earth. And it did not happen only once. The pressure wave kept moving. It traveled east. It traveled west. It circled the globe again and again. For days, instruments kept picking it up. The wave passed over the same places multiple times, weaker each time, but still there. Imagine being a scientist at the time, looking at those readings. A volcano in Indonesia erupts, and suddenly your instrument in Europe moves. Then it moves again, then again. Days later, the atmosphere is still reacting. That had never really been seen like this before. There was no easy category for it. A normal blast should send out a pulse. That pulse should spread, fade, and disappear. But this wave seemed organized. It held together long enough to circle the planet several times. That was the part people struggled to explain. The explosion itself was already beyond belief, but the way the pressure wave behaved made the event even stranger. It was not just a loud eruption. It was a global atmospheric event. For 5 days, the air kept carrying the message. Krakatoa had spoken once, but the planet kept repeating it. And that detail changes how you think about the disaster. Because the people near the volcano were fighting for their lives. They were facing ash, darkness, heat, waves, and destruction. But far away, in quiet cities, instruments were also recording the same event in their own cold way. No screaming, no flames, just a needle moving on paper. That is haunting. A town can vanish, and somewhere across the world, the only sign is a small line jumping on a machine. But that small line mattered. It proved that Krakatoa had not stayed local. The blast had connected the Sunda Strait to the rest of the planet. The eruption became something measurable on a global scale. And remember, this was 1883. No satellites, no live video, no instant global data network like we have now. Yet the atmosphere itself carried the news. The pressure wave told scientists that something enormous had happened before many people even understood the full scale of the deaths, the tsunami, or the island's collapse. That is why Krakatoa still feels so powerful today. It was not just an explosion heard around the world. It was an explosion felt by the sky. And for days after the volcano went quiet, the air kept shaking with its memory. After Krakatoa exploded, scientists tried to make sense of what had happened. And honestly, you can understand why. This was not a normal eruption. The sound had traveled across oceans. The pressure wave had gone around the Earth again and again. Skies were changing color on different continents. Ships had been damaged. Whole towns were gone. People needed an explanation. So in London, the Royal Society created a special committee to study the disaster. They gathered reports from all over the world. Ship logs, weather station records, barometer readings, eyewitness accounts, sketches of strange sunsets, photographs, letters. It was a huge effort for that time. Hundreds of people contributed. The final report became one of the most detailed scientific studies ever made about a single natural disaster. But even with all that work, some questions did not fit cleanly. That is the important part. Science had records. It had numbers. It had testimony. But Krakatoa was bigger and stranger than the categories people had at the time. They knew about lava flows. They knew about ash columns. They knew about mud flows and hot volcanic clouds. They had studied volcanoes like Vesuvius and Etna for years. But Krakatoa did not behave like a textbook example. The pressure wave was one of the biggest problems. A single explosion should create a pulse. That pulse should move outward, weaken, and fade away. That is what people expected. But Krakatoa's pressure wave kept traveling. It crossed the planet multiple times. It showed up on instruments again and again. It was as if the atmosphere had been turned into one huge, vibrating system. The scientists could describe what they saw, but explaining why it held together for so long was much harder. There was also the question of the sound itself. Near the volcano, it was not just noise. It was physical force. It injured sailors. It burst eardrums. It turned the air into something dangerous. How do you describe a sound that stops being sound and becomes impact? That was not easy for 19th century science to handle. And then there were the details that did not make it smoothly into the final story. Some ideas were too speculative for the official report. Some conclusions were softened. Some parts were removed before publication. The final document was impressive, but it was also cautious. That matters, because sometimes official reports do not show confusion clearly. They make disasters look cleaner than they really were. They organize the facts. They remove uncertainty. They turn chaos into chapters. But Krakatoa was not clean. It left behind broken instruments, missing towns, conflicting death records, injured sailors, strange skies, and a pressure wave nobody fully understood at the time. The scientists did their best with the tools and language they had. But the disaster had outrun their understanding. And that is the lesson here. A report can be careful and still incomplete. A committee can collect the truth and still not know what the truth means. Krakatoa forced science to catch up after the fact. By the time the world had a better explanation, the island was already gone. After Krakatoa exploded, the disaster did not stay near Java and Sumatra. It went into the sky. The volcano threw an enormous cloud of ash, dust, and sulfur high into the atmosphere. Not just into the lower air where weather happens. Much of the finest material reached the stratosphere, where it could stay for a long time and travel around the world. That is when people far from Indonesia started seeing things they could not explain. In London, sunsets became unusually bright. The sky looked like it was burning. In parts of New York, people saw such a strong red glow on the horizon that firefighters were reportedly called out because witnesses thought there was a huge fire somewhere in the distance. But there was no fire. It was the sky itself. That is one of the most haunting parts of Krakatoa. People thousands of miles away were looking at the after effects of the eruption without knowing what they were seeing. They were not near the volcano. They did not hear the blast. They were not running from waves or ash. They were just standing under strange, beautiful skies. And those skies were carrying the disaster. The fine volcanic particles spread around the planet. They bent and scattered sunlight in unusual ways. Sunsets turned deep red, orange, copper, and sometimes even greenish or blue. The sun itself could look strange at sunrise or midday, depending on where the particles were moving overhead. Imagine walking outside one evening and seeing the horizon glowing like a furnace. No smoke nearby, no flames. Just the whole edge of the sky lit up in colors that feel too intense to be normal. That is what people saw for months. And in some places, the strange sunsets continued for nearly 2 years. It sounds almost beautiful, and maybe that is what makes it so unsettling. Krakatoa produced some of the most stunning skies people had ever seen, but those colors came from destruction. They came from an island being torn apart, from towns being erased, from tens of thousands of lives lost in a single morning. The beauty was real, but so was the cost. This is why the red skies matter so much in the story. They show how far a volcanic disaster can reach. Krakatoa did not only kill people near the Sunda Strait, it changed the way the whole planet looked. Artists noticed it. Astronomers noticed it. Newspapers wrote about it. Ordinary people looked up and wondered what was happening. And today, when we look back at those reports, we can see the connection clearly. The red sunsets were not random weather. They were Krakatoa's fingerprint in the atmosphere. That is a strange thought. A volcano erupts in the Indian Ocean, and weeks later, someone in Europe or America sees the sky turn red because of it. No internet, no live broadcast, no satellite image, just sunlight passing through volcanic dust, quietly telling the world that something enormous had happened. Krakatoa turned the atmosphere into a message, and for a long time after the sound faded, the sky kept repeating it. One of the strangest things Krakatoa left behind was not on the ground, it was in the sky. Weeks after the eruption, people around the world kept seeing unusual colors near the sun. The sunsets were intense, but there was also something more specific. A faint ring, a pale halo around the sun that did not look like normal weather. In Hawaii, a missionary and amateur astronomer named Sereno Bishop watched it closely. He did not just glance at the sky and move on. He paid attention. Evening after evening, he looked toward the horizon. He kept notes. He used a telescope. He watched the way the light changed. What he saw was a soft brownish ring around the sun. It was not a rainbow. It was not a cloud passing by. It seemed to travel with a high layer of volcanic material moving through the upper atmosphere. That ring later became known as Bishop's Ring. And it became important because it gave scientists a visible sign of something happening far above normal weather. The finest particles from Krakatoa had reached the stratosphere. That is high enough for them to spread around the planet and stay there for a long time. Most of the heavy ash fell out quickly, but the tiny particles stayed. Sulfur droplets, fine volcanic dust, microscopic pieces of the eruption. They floated high above the earth, catching sunlight and scattering it in strange ways. That is why people saw red sunsets, blue suns, copper-colored light, and halos that seemed to hang in the sky. Bishop's Ring was basically Krakatoa's signature, a fingerprint written in sunlight. And that is what makes it so powerful. The eruption had already destroyed towns near the Sunda Strait. It had sent waves into coastlines. It had thrown pressure through the atmosphere. But now, even people far away could look up and see proof that the disaster was still moving around the planet. Not as fire, not as sound, as dust and light. Later, scientists would see similar rings after other major volcanic eruptions. So, Bishop's observations became more than just a strange sky report. They helped show that big eruptions can leave global marks in the atmosphere. That matters because volcanoes do not only affect the place where they erupt, They can change the air above continents. They can change sunlight. They can cool temperatures. They can disturb weather patterns and growing seasons. Krakatoa helped reveal that connection. And the strange thing is, this global clue was visible to ordinary people. You did not need to stand on Krakatoa. You did not need to be a scientist in London. You could be on an island in the Pacific, looking at the sun through a strange halo, and you were still seeing part of the same disaster. That is hard to forget. A volcano explodes in Indonesia, and weeks later, the sky over Hawaii carries the evidence. Bishop's Ring was beautiful in a quiet way. But it was not just beauty. It was a warning written across the atmosphere, showing that the planet is more connected than people wanted to believe. Krakatoa did not stop affecting the world after the explosion faded. The sound was gone. The tsunami had already done its damage. The island was broken, but high above the earth, the eruption was still working. Krakatoa had thrown fine volcanic particles and sulfur into the upper atmosphere. The heavy ash fell back down pretty quickly, but the tiny particles stayed up there. They spread around the planet and formed a thin layer that changed how sunlight reached the ground. It does not sound dramatic at first. A little less sunlight, a small drop in temperature. But small changes in climate can hit real life very hard. Through 1884, temperatures in the northern hemisphere dropped. The number was not huge on paper, but farmers do not live on paper. Crops depend on timing. They need enough warmth at the right moment. They need seasons to behave the way people expect. And after Krakatoa, the seasons did not behave normally. In parts of Europe, the summer of 1884 was unusually cold. Wheat fields that should have been ripening stayed green too long. Harvests were delayed. Some crops did not mature the way they should have. That is the kind of thing that can scare a farming community fast. Because when a field does not ripen on time, it is not just a weather problem. It becomes a food problem, a money problem, a survival problem. In wine regions, the impact showed up in another way. Grapes struggled. Some harvests produced fruit that was too acidic. Whole vintages were damaged. For farmers and winemakers, that meant months of work ruined by a sky they could not control. Across the ocean, the winter of 1884 to 1885 was harsh in parts of the northeastern United States. New York Harbor froze hard enough to stop ferries and trap ships in ice. People at the time tried to explain the strange cold in whatever way made sense to them. Some blamed icebergs or unusual weather patterns, but the real cause was high above them. Volcanic particles were reflecting sunlight back into space. Less sunlight reached the lower atmosphere, so the air cooled. Today, that process is understood much better. Scientists call it volcanic forcing. A major eruption can send aerosols into the stratosphere, and those particles can cool parts of the planet for months or even years. But in 1883 and 1884, people did not have that full picture. They saw the results before they understood the cause. Red skies, cold summers, late crops, frozen harbors, bad harvests, and all of it was connected to one volcano far away in the Sunda Strait. That is what makes Krakatoa so important. It showed that a volcano does not have to be near you to change your life. You can live on another continent, never hear the explosion, never see the ash fall, and still feel the impact in your weather, your food, your work, and your wallet. The eruption was not just a local disaster, it became part of the climate. And once that happens, distance does not protect anyone. There is one part of the Krakatoa story that feels almost unreal. It may have reached into art. Months after the eruption, the skies over Europe were still strange. The sunsets were not normal sunsets. They were deep red, orange, and almost bloody in color. Long bands of light stretched across the horizon. People noticed. They wrote about it. Some were amazed, some were scared. And in Norway, a young artist named Edvard Munch may have seen one of those skies. Years later, Munch described a walk near Christiania, the city we now call Oslo. He said he was walking along a road when the sky suddenly turned blood red. He stopped. He felt overwhelmed. He described the clouds as stretching across the sky like waves of fire. That moment stayed with him. And eventually, it became connected to one of the most famous paintings in the world, The Scream. Now, To be clear, we cannot say with absolute certainty that Krakatoa directly created that painting. Art does not work that simple. A painting comes from memory, fear, emotion, imagination, and the artist's own life. But the timing is hard to ignore. Krakatoa erupted in August 1883. The strange volcanic sunsets spread across the world in the months that followed. Northern Europe saw those intense red skies during that same period, and Munch's description of the sky matches many reports of Krakatoa's afterglows. That does not prove everything, but it makes the connection powerful, because when you look at the scream, the sky is not just a background. It feels alive. It feels heavy. It feels like the world itself is pressing down on the person standing there. The colors are beautiful, but they are also disturbing. That is exactly what a volcanic sky can feel like when people do not understand what they are seeing. Imagine standing outside at sunset, and the whole horizon turns the color of blood. No fire nearby. No storm you can explain. Just the sky changing into something that feels wrong. You would remember that, and Munch did. That is why this possible link matters. It shows how far Krakatoa's influence may have traveled. Not just through air pressure, not just through ash, not just through climate and crops, through human feeling. A volcano exploded in the Indian Ocean, and months later, someone in Norway may have looked up and felt the sky scream. That is the strange reach of this disaster. It moved through oceans, it moved through the atmosphere, it moved through weather, and maybe, in some quiet way, it moved through the mind of an artist. Krakatoa did not only leave scars on coastlines, it may have left a mark on the way the world remembers fear. For years, people knew Krakatoa had exploded. They knew the sound had traveled across the world. They knew the pressure wave had circled the planet. They knew the tsunami had erased towns. They knew most of the island was gone. But the big question stayed there. What actually caused that kind of explosion? Because Krakatoa did not behave like a normal volcano. It was not just lava coming out of a crater. It was not just ash shooting into the sky. Something deeper had happened. The answer is simple to say, but terrifying to picture. Seawater met magma. That is where the real violence came from. During the first explosions, Krakatoa's magma chamber began to empty. As magma blasted upward and out, the chamber below the island lost support. Think of it like removing the inside support from a building while the roof is still sitting on top. At some point, the roof could not hold anymore. It cracked, then it collapsed. And because Krakatoa stood in the sea, that collapse opened a path for ocean water to rush downward into the volcanic system. That is the nightmare scenario. Cold seawater pouring into a chamber filled with magma hotter than most people can even imagine. The moment that water touched the magma, it flashed into steam. Not slowly, instantly. Water expands violently when it turns into steam, and when that happens inside a confined space, the pressure becomes almost impossible to contain. It is like sealing water inside a boiler, heating it far beyond the breaking point, and then letting the whole system fail at once. Only this was not a boiler. It was an island. That is why Krakatoa did not just erupt. It collapsed and detonated. The explosion was powered by magma, seawater, pressure, and a chamber that could no longer hold itself together. This kind of eruption is called phreatomagmatic, which basically means water and magma are interacting in an explosive way. And at Krakatoa, the scale was enormous. We are not talking about a little splash of water hitting hot rock. We are talking about huge amounts of seawater pouring into a volcanic chamber, turning into superheated steam in seconds, and blasting outward with unbelievable force. That explains why the explosion was so loud. It explains why the pressure wave was so powerful. It explains why the island tore itself apart instead of simply venting from the top. And it explains why the danger was not only above the volcano, but all around it. The energy did not just go upward into the sky. It moved sideways too. Hot gas, ash, and rock blasted across the surface of the sea. The collapse also pushed massive amounts of water outward, helping create the tsunami that struck nearby coasts. This is what makes Krakatoa so frightening. The ocean was not just sitting beside the volcano. The ocean became part of the explosion. People often think water should calm fire down, But inside a volcano, water can do the opposite. It can turn heat into pressure. It can turn pressure into a blast. And if the structure above it fails, it can help turn a volcanic eruption into something much worse. Krakatoa was not just a mountain blowing its top. It was a whole system failing at once. Rock cracked, the chamber emptied, the roof collapsed, the sea rushed in, the magma flashed it into steam. And in that moment, the world heard the result. The tsunami was not the only thing that made Krakatoa so deadly. There was something else, something even harder to imagine. A wall of burning gas and rock crossed the sea. That sounds impossible at first. We usually think of volcanic destruction moving down the side of a mountain. Hot ash, gas, and rock racing through valleys. That is already terrifying. But Krakatoa did something different. Its pyroclastic surges did not stop at the shoreline. They moved across open water. A pyroclastic surge is not like a slow lava flow. It is fast, violent, chaotic. It is a cloud of superheated gas, ash, and broken rock, moving at incredible speed. The temperature can be hundreds of degrees, in some cases hot enough to burn lungs, skin, clothing, trees, and buildings almost instantly. And during Krakatoa's great explosion, these surges blasted outward across the surface of the sea. One of them reached the coast of Sumatra about 40 miles away. 40 miles. Across open water. That is the part that makes Krakatoa feel different from almost any normal eruption. People on that coast were not standing on the volcano. They were not at the base of the cone. They were far away, separated by the sea. They had every reason to believe distance gave them some protection. It did not. On the Sumatran coast, the sky had already been dark since morning. Ash blocked the light. The air felt wrong. Then, after the huge explosion, the pressure dropped so sharply that doors pulled inward and windows cracked. A Dutch official named Willem Bijgerink saw what was coming. He looked toward the strait and saw something moving over the water. He later described it as a wall of fire. It was rising from the sea and racing toward shore like a fast train. Think about that moment. You are standing near the coast. The sky is black. The volcano is miles away. Then you look out across the water and see a burning wall coming straight at you. There is no time to plan, no time to save belongings, no time to warn a whole village. Maybe 2 minutes. That was all. Bijgerink and his wife ran inland, away from the beach, into the palms. Then the surge arrived. It was not like standing near a fire. It was total heat, the kind of heat that steals the air from your lungs, the kind that burns through clothing, the kind that turns trees and roofs into flame almost immediately. The palms bent and caught fire. Ash on the ground was hot enough to burn through boots. Embers hit their backs as they kept moving. Somehow, they survived, burned, injured, and shaken, but alive. Nearly 1,000 people along that stretch of coast did not. That is the part numbers cannot really carry. You can say 40 miles away. You can say hundreds of degrees. You can say almost 1,000 dead. But none of that fully explains what it must have felt like to see a glowing cloud come across the sea on what had been a normal morning. The worst part is that it arrived almost without a warning people could use. There was no modern alert, no phone message, no siren system. No map showing where the hot cloud would go, just darkness, pressure, heat, and then the wall. Krakatoa proved that a volcano surrounded by water can still kill far beyond its island. The sea did not stop the surge. It carried the terror farther than anyone expected. After the explosions, the sea became the next killer. And that is what most people remember about Krakatoa. The blast was terrifying. The sky was black. Hot ash was falling. Burning clouds had crossed the water. But for the towns along the coasts of Java and Sumatra, the greatest destruction came when the ocean suddenly rose and came inland. This was not a normal wave. It was a wall of water. In some places, the tsunami was more than 100 feet high, that is taller than a 10-story building. Try to imagine standing near the shore and seeing that coming toward you. There is no real way to outrun something like that if you are too close. The wave hit coastal towns with brutal force. Buildings were torn apart. Trees were ripped out. Boats were smashed or thrown inland. People were swept away before they could understand what was happening. Whole communities disappeared in minutes. One of the strongest images from this disaster is the Dutch warship anchored near the Sumatran coast. It was sitting in the harbor, where a ship is supposed to be safe. But when the tsunami came, the water lifted it like it weighed almost nothing. This was a heavy warship, hundreds of tons of metal and wood, and the wave picked it up, carried it inland, and dropped it far from the shoreline. Later, surveyors found the ship lying on its side about 2 miles from the sea, resting above normal sea level in mud, broken trees, and wreckage. The crew did not survive. That one detail tells you more than any number can. A ship built for the ocean ended up stranded on land, not near the beach, miles inland. That is the kind of evidence you cannot argue with. It shows the power of the wave better than any official report could. The sea had not simply flooded the coast. It had grabbed ships, buildings, people, and entire towns and dragged them into a new shape. And for the people living there was almost no time. The tsunami came after the island had already begun collapsing. The eruption had blasted away huge parts of Krakatoa. Seawater rushed into the broken volcanic system. The land failed. The ocean was displaced. And then, the energy moved outward across the strait. The coasts were trapped. They were close enough to be hit fast, but far enough that many people may not have understood the danger right away. That is one of the cruel things about tsunamis. The water may pull back. The sea may look strange. The horizon may change. But if people do not know what those signs mean, the warning becomes useless. In 1883, there were no emergency alerts, no phones, no sirens, no tsunami evacuation maps, no clear way to tell every coastal village, run uphill now. So the wave arrived as a surprise to many, and when it hit, it erased places from the map. This is why Krakatoa was not only a volcanic disaster, it was an ocean disaster too. The volcano broke the island, but the sea carried the destruction into human lives. By the end of that morning, thousands were gone. Ships were inland, coastal towns were ruined, and the shoreline itself had become a graveyard. By the end of August 27, Krakatoa was no longer the same island. A huge part of it was simply gone. That is hard to picture. We are not talking about a crater on top of a mountain. We are talking about most of the island collapsing and vanishing into the sea. What had stood above the water before the eruption was broken open, torn apart, and swallowed. Before the disaster, Krakatoa had been a volcanic island with high cones rising out of the Sunda Strait. Ships could see it from the water. It was a landmark, a dangerous one, maybe, but still, a real island people could point to on a map. After the eruption, that island had changed into something almost unrecognizable. The explosions had emptied part of the magma chamber below. The roof of that chamber lost support. Then the land above it failed. When the structure collapsed, seawater rushed into the space left behind. And once the sea filled that void, Krakatoa was no longer just damaged. It had become an underwater crater. Most of the old island was beneath the surface. What remained above water was only a broken piece, a steep wall of bare volcanic rock. It was like seeing the inside of the volcano exposed to the open sky. That image says everything. The mountain had been cut open. The sea now sat where solid land used to be. The same volcano that had sent a sound around the world had erased much of its own body in the process. And for the people who survived, the landscape itself must have felt wrong. The island they knew was gone. The coastlines nearby were wrecked. Ships had been thrown inland. Villages had disappeared. The sea was filled with debris, ash, pumice, bodies, broken wood, and pieces of a world that had existed only hours earlier. Disasters often leave ruins behind. Krakatoa left an absence, a missing island. That is what makes this part so haunting. After all the noise, all the waves, all the fire and ash, there was suddenly silence over a place that had been ripped open from below. The volcano did not die exactly. It sealed itself. The collapsed chamber filled with seawater. The weight of that water pressed down over the broken system. For decades, the Sunda Strait grew quiet again. To anyone passing through years later, it might have seemed like the disaster had ended for good. But that was not true. Under the water, the volcanic system was still there. The crater remained. The heat remained. The deep connection to the tectonic forces below remained. Krakatoa had not disappeared because the Earth was finished with it. It had disappeared because one cycle had ended, another one was waiting. For 44 years, the sea covered the wound. Then, in 1927, fishermen would see steam rising from the water, and Krakatoa's child would begin to appear. For 44 years, the Sunda Strait stayed quiet. At least, it looked quiet from the surface. The old Krakatoa was gone. Most of the island had collapsed into the sea. The crater was underwater. Waves moved over the place where the volcano had torn itself apart. To anyone passing by, it may have seemed like the disaster was finished. But volcanoes do not always end when the land disappears. Sometimes they just go silent. Deep below the water, the same system was still there. The heat was still there. The magma source was still there. The old crater was not dead. It was covered. Then, in December of 1927, fishermen in the Sunda Strait saw something strange. Steam was rising from the sea, not from an island, from the water itself. At first, it must have looked unreal. A patch of ocean breathing like the ground beneath it was alive. And in a way, it was. Krakatoa had not vanished forever. It was coming back. The steam continued. Then, ash and pumice began to appear. Over time, material built up from below the surface. The volcano was slowly pushing itself back into the world. Within a few years, a new ridge of black volcanic rock and ash broke through the sea and stayed above water. People gave it a name. Anak Krakatau, the child of Krakatoa. That name is simple, but it carries a lot of weight. This was not just a new island. It was the return of the same volcanic system that had killed more than 36,000 people in 1883. The parent had destroyed itself. The child was now growing from the wound, and it kept growing. Over the next decades, Anak Krakatau erupted again and again in smaller bursts. Each eruption added more material: ash, lava, pumice, rock. Little by little, the new cone rose higher out of the sea. It was like watching the earth rebuild a weapon piece by piece. That may sound dramatic, but that is what makes this place so unsettling. The 1883 disaster was not a one-time accident. It was part of a cycle. Pressure builds. The volcano grows. The structure weakens. The sea surrounds it. And sooner or later, the system changes again. Anak Krakatau became one of the most active volcanoes in the region. Scientists watched it closely. Boats passed near it. Cameras recorded it. Satellites later tracked it from above. But the basic danger never left. A young volcanic island growing out of an old underwater crater is not stable forever. It is new land, built from loose volcanic material, sitting in the sea, rising over a system that had already shown how violent it could become. That is the uncomfortable truth. Krakatoa did not die in 1883. It reset. The sea covered the old crater for a while. Then the volcano found its way back to the surface. And when Anak Krakatau appeared in 1927, it was not just a geological curiosity. It was a warning. The child of Krakatoa had been born. And one day, it would remind the world what family it came from. In 2018, Krakatoa's story came back in a way that felt painfully familiar. This time, it was not the old island from 1883. It was Anak Krakatau, the child of Krakatoa. By then, the new volcano had been growing for decades. It had risen out of the sea from the old crater and become one of the most active volcanoes in Southeast Asia. Scientists watched it. Satellites passed overhead. Seismographs were running. There was an observation station nearby. So on paper, this was not an unknown volcano. It was being monitored. And still, disaster came. On the night of the 22nd of December 2018, part of Anak Krakatau suddenly collapsed into the sea. The southwestern side of the volcano gave way and slid underwater in a matter of minutes. That is all it took. A huge section of the cone dropped below the surface, pushing water outward. The ocean reacted fast. A tsunami formed and raced toward the coasts of western Java and southern Sumatra. The worst part was the timing. It happened at night. The sea was calm. There had been no major earthquake to warn people. No violent shaking that made everyone run outside. No obvious signal that a tsunami was coming. And the warning system at the time was mainly built to detect tsunamis caused by earthquakes. This one was different. It was caused by the side of a volcano collapsing into the water, so the wave came without a formal warning. Within about 25 minutes, it reached the coastline. People along the shore had almost no chance. Some were at home, some were near beaches, some were attending events. Many did not even know anything had happened offshore until the water was already there. More than 400 people died. Thousands of homes were damaged or destroyed. And just like in 1883, the painful lesson was not that nobody was watching the volcano. People were watching. The instruments were working. Data was being collected. But the meaning of that data did not turn into a warning fast enough. After the disaster, scientists looked back at the signs: gas emissions, seismic activity, changes in the shape of the cone, slow movement that suggested instability. In hindsight, the clues were there, but hindsight is cruel. It always makes the pattern look clearer after people are already gone. That is what makes the 2018 disaster so disturbing. It happened in the modern world, a world with satellites, sensors, computer models, and real-time monitoring. And still, a volcanic flank collapse moved faster than the warning system. The mechanism had not changed much since Krakatoa's older disaster. Volcanic land built in the sea can become unstable. A cone can grow too steep. One side can weaken. Then, gravity does the rest. When enough material falls into the ocean, the water has nowhere to go but outward. That outward push becomes a tsunami. And if people live close to the shore, minutes matter. In 1883, Krakatoa killed more than 36,000 people in one morning. In 2018, Anak Krakatau killed more than 400 people in a quieter, darker way. Smaller scale. Same family of danger. That is the part that should stay with us. The volcano had been known. The volcano had been watched. The coastline had not moved. But when the collapse came, the warning still arrived too late. Krakatoa did not repeat itself exactly. It reminded us. This is the lesson Krakatoa keeps teaching. The problem is not always that we lack information. Sometimes the information is right there. The instruments are working. The reports are coming in. The experts are watching. The data is being collected day after day. And still, the warning comes too late. That happened in 1883. Krakatoa had been watched for months. Steam was rising. Earthquakes were happening. Ash was falling on ships. The sea was changing color. Pumice was floating everywhere. Scientists and officials recorded the activity. Captains wrote it down in their logs. The signals were there. But they were not understood in time. People saw a volcano waking up. They did not see a system moving toward collapse. That difference cost tens of thousands of lives. And then, more than a century later, the same kind of lesson appeared again with Anak Krakatau in 2018. This time, the world had better tools: satellites, seismometers, gas sensors, observation stations, modern scientists, faster communication, more knowledge than anyone had in 1883. But when the side of the volcano collapsed into the sea, the tsunami still came without a useful warning for the people on the coast. That is what should bother us. Not because the scientists were careless, not because nobody was watching, but because watching is not the same as predicting. A volcano can be monitored closely and still surprise us. The data can be real and still unclear. The pattern can be visible only after the disaster has already happened. After 2018, people could look back and see the clues: the changing shape of the cone, the seismic activity, the gas emissions, the signs of instability. In hindsight, the story looked more obvious. But hindsight always feels smarter than the moment itself. In real time, signals are messy. They do not arrive with labels that say, "This is the final warning." They come as small changes, strange readings, unusual patterns, and details that can mean more than one thing. That is why Krakatoa matters today. It reminds us that technology does not remove uncertainty. It only gives us a better view of it. We like to believe that modern instruments make disasters predictable. We want to think satellites in the sky and sensors on the ground can turn danger into a clear schedule. But nature does not hand us a calendar. It gives signals, and humans have to read them. That is where the weakness is. The same volcano system showed this across 135 years. In 1883, the warning signs were recorded but misunderstood. In 2018, the warning signs were measured with modern tools, but the real-time interpretation still arrived too late. Different century, better technology, same painful gap. Data is not protection by itself. A sensor does not save anyone unless its message becomes action. A report does not move people uphill. A satellite image does not stop a wave. A warning only matters if it is understood early enough to change what people do. That is the hard truth. Krakatoa was not just a disaster of the past. It was a reminder that the most dangerous moment may not be when nature is silent. It may be when nature is speaking clearly, and we still do not know how to listen.